So at this point, if you want to speak, your voice will be recorded and uploaded on YouTube forever. Okay. All right. Any questions about the first one? Let me go through the steps slowly one by one more time. So my first step is to identify the chord. In this case, the chord is a sine. So I sketch the sine graph, and I identify the ABCD parameters, and I write down the meaning of each letter. So in this case, A is -1, so it's vertical stretch by 1, and vertical reflection, yes. B equals 1/3, so horizontal stretch by 3, and no horizontal reflection. C equals -pi, so horizontal translation by pi. D equals 0.5, so vertical translation by 0.5. So I do the steps, and you don't need to memorize the order of each. You just need to go 1, 2, 3, 4, 5, 6. Hi.
Why is there no horizontal stretch?
You mean no horizontal reflection?
Yeah.
Because it's positive. The reflection only happens when it's negative. When A or B is negative, it's reflection. So I do the transformation one by one. I mean, if you're good at it, you can do multiple transformations at once. For example, you can combine the vertical stretch and vertical reflection together into one. Or you can combine stretches into one, or so on. But make sure that you're going in that direction. Anyways, after I do all the transformation, I still don't have the y and x-intercepts. So I find the y-intercept by plugging 0, find the x-intercept by plugging y equals 0, solve the trig equation, so I label the intercepts. So, yay me, I'm happy. Alright. So, the second question on the bottom side, I'll leave it empty, so it's up to you. Hi.
Let's say you don't use transformations, you just do it where you find x-intercept, y-intercept, and then you plug in the x-intercepts and the maximum minimums, and that's the same thing, right?
It's the same thing. So yes, if you want to use y-intercept, x-intercepts, and then you can use the two x-intercepts to deduce where the max and mins are, you can compute the values of it. Or you can use a mixture of two. You can use a transformation to just find the max and mins, and do that however you want, whatever method you take. The final result should look like this. It should have a correct graph. It should have the relative correct location of things. For example, if your y-intercept is on the negative side, then it means it's not good. Right? Also, you should have all your intercepts labeled, and you should all have your max and mins labeled properly. The midpoints don't matter. So if you want to erase these ones, that's okay. These are not important. Important things are max and mins and the intercepts. Hi.
Why can't the y-intercept be on the negative?
Well, because it's positive 1.366. So if you have drawn it here and say, oh, it's 0.136, then it's incorrect shape.
And wait, how do you find the maximum minimum?
Max and mins without using the transformation. So let's say I don't know this one. So one thing that I know about the max and mins is that they're always in the middle of two x-intercepts. So if I know that 3π/2 and 7π/2 are two x-intercepts, then the middle of it, which is 5π/2, must be either max or min. So, okay, coordinate is 5π/2. So you plug it in, put it into the calculator, you get -0.5. And you're like, oh, -0.5 must be my minimum. And then you do the same thing. The next one here, according to this calculation, 3π/2 plus 6π, this is 15π/2. So what is the middle of 15π/2 and 7π/2? 11π/2. So you put 11π/2 into the formula, and you get 0.5, and you're like, oh, that must be the maximum. Does that make sense?
That's the maximum x-intercept that you plug into the y.
To get the maximum y coordinates.
Oh, okay.
Then you know the coordinate of both coordinates of the max and mins. However you want. Alright, let's move on to the yes.
And for x, I mean like y-intercept.
Yeah.
like I plug minus sine blah 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 into a calculator and I got like 0.518 something.
Let me guess. Is it in degree mode?
Oh, thank you.
It's great that you're asking questions here. You don't want to ask them during the class time and say, hey, I'm not getting the correct answer. Or, hey, I don't know how to do the log base. You don't want to ask that. I can't answer that question. So, now, let's move on to question 3. So question 3 is the other way around. I give you the graph and I ask you to find the equation of it. So once again, if I want to, I can use your own methods of finding the A, B, C, D values. I'll use the idea of the transformation here once again. Okay? So once again, the first question is, we need to identify what the core is. What should be the core of this function?
Cosine?
Cosine. Sure thing. If you do cosine, the question is very, very simple. So I suggest that you do that. Just for the sake of practice, I'm just going to use the sine. Okay? So I chose, okay, this is not a mathematical fact. I chose that sine of x is my core of this function. Okay? Once again, it's a lot easier if you do cosine. In general, cosine is a lot easier. But let's assume that I chose sine to be my core. So after I identify the core, what do? I need to sketch the sine of x. So let me sketch the sine of x on this graph. Starting from the midpoint, 0, 0. It takes 2 pi for me to complete the cycle. So it goes up and down and up. Pi over 0, pi over 2, 1, and pi over 2, -1. So now the question is, now I'm being a detective. I look at this crime scene and I say, hey, how did the red graph become the black graph? Okay, one more time. The question is, how did the red graph become the black graph? Well, I know it must have been done in 6 different transformations. 3 and vertical and horizontal for each. The total of 6. So let's study this case. First, the vertical stretch. Is there some kind of a vertical stretch in this question?
No.
My red graph goes from -1 to 1, and the black graph goes from -3 to 1. So there has to be a vertical stretch. By how much? By 2. All right, because my red graph has the amplitude of 1, and the black one has an amplitude of 2. So there has to be a vertical stretch. What about vertical reflection? Is there a vertical reflection?
No.
No. But yes, it's also possible. In general, I suggest don't put vertical reflection. Just personal suggestion. Don't bother about vertical reflection nor horizontal reflection. So just say no. What about the horizontal stretch? Is there a horizontal stretch in this crime scene? The red graph has a period of 2 pi. It takes 2 pi to complete one cycle. What about the black one? The black one also takes 2 pi to complete one cycle. In other words, there's no horizontal stretch, so we can say a horizontal stretch by 1. Stretching by 1, it means nothing has happened. And the horizontal reflection, also, you could say yes, but just say no. Okay. Now, we need to do the horizontal translation and vertical translation. For this part, I suggest that you do the vertical translation first. So the question is there a vertical translation for this function? Did my graph go up and down? and by how much? Reminder that we've already done the vertical stretch by 2. So now at this point, my graph goes from -2 to +2. -2 to +2, -3 to 1. So what happened? I need to sync it by moving down by 1. So I think we can say, for its vertical translation, by -1. My graph has to fall 1 step below. The one final piece is the horizontal translation. How much did my graph move left and right? This one also has multiple answers to it, but I think it's easiest for me to say my pi/2, 1, the maximum, has moved to the left by pi/2. So I'm going to say horizontal translation by -pi/2. The red graph, look at this maximum, it moves left by pi/2. If you want to say move to the right by 3 pi/2, that's okay. That's also acceptable. So it's either left by pi/2 or right by 3 pi/2.
But the black graph didn't move. I'm assuming.
Right, but right now, if I do all the transformation, it's going to look like this. It's going to look like that. So now we need to do one final sync by moving left by pi/2. Then it'll be completely overlapping. By observing the maximums. When you do the transformation, literally you're moving the images around and flipping around and enlarging it. It's always important that you have one, like a set point. Okay, we match this point, and then everything becomes easier. For example, if you want to take a good picture of a person, and you want to put the foot of the person on the bottom edge of the photo. So your picture, the foot is literally on the bottom of the photo. Then you can take a good picture. That's an example of, hey, I need to have a set point of this graph. In this graph, I suggest maximum. You move the maximum, and everything else will automatically follow. Anyways, so I know exactly what has happened in this transformation. So I just need to write down the meaning of each letter. Vertical stretch by 2 and no vertical reflection. What does that mean about my A value? 3, 2, 1. Okay. I'm looking for my A value. Vertical stretch by 2 and no vertical reflection. So what is A value?
+2.
+2. What about my B value? It's 1. What about my C value? pi/2. Remember that it's opposite of it, so opposite of -pi/2 is +pi/2. And my D value, -1. So my final answer, y is equal to 2, my base is sine, B is 1, C is pi/2, and D is -1. So voila. Once again, it is highly likely that you have a different answer. For example, if you use the cosine, it may look something like 2 cosine of x minus 1. Or you could also say, oh, it's -2 sine of x minus pi/2. Sure, whatever you want. I'll accept all possible answers. Although cosine is easier, I suggest that you practice both sine and cosine, because some questions will be asking you, you need to find it in terms of sine, or you need to find in terms of cosine.
Would it not be the same answer though for sine and cosine?
It won't be the same parameters. It'll be like 2 cosine of x minus 1. So if you say cosine of x plus pi over 2, that's incorrect. There are infinite number of answers. So. Once again, do you need to go this method? Not at all. If you thought that your previous methods of knowing your max and mins and finding the amplitude, finding the midpoint, knowing the a and d value, and then computing the b value by using the period, and then using the c value to calculate the c value using the trig equation, whatever you want, go for it. If you want to combine both, that's also fine. Let's move on to the question 5. Now we're doing the tangent equations. So once again, let's start with the first step. The first step is to identify the core. So what is the core of this function? 3, 2, 1. Tangent function. This is a tangent function. So let's sketch the tangent function on the side. Once again, it's always useful if you memorize this. Tangent function goes through 0, 0. And a graph looks like that. And my first vertical asymptote is at negative pi over 2. And the next one is x equals pi over 2. And it'll repeat every pi. The period of the tangent function is I suggest that you memorize this shape as well as the key features such as the vertical asymptotes and the x-intercepts. The next step, my third step, after I identify the core and sketch the core, is to write down the parameters. A, B, C, and D. I'll give you 10 seconds to do that. Oh, A equals -1, B equals 0.25, C equals negative pi over 2, and D equals 0. Okay. The next step is to explain. What is the meaning of A equals -1? What is the meaning of B equals 0.25? So let's start with it. I'll go slow, so if you want to get ahead of me, you can do that. First thing, A equals -1. A is responsible for two things, the vertical stretch and vertical reflection. So, A equals -1. 1. So vertical stretch by 1. Vertical reflection, A is -1. Negative, so yes, reflection. B value is responsible for the horizontal stretch and horizontal reflection. First of all, B equals positive 0.25. 0.25, isn't that a 1/4? 1/4? So horizontal stretch by 4. And horizontal reflection, no reflection. It's positive, so no reflection. And the horizontal translation, C equals negative pi over 2. So we're actually translating by positive pi over 2. And lastly, vertical translation by 0. So let's do it one by one. This time I'll try to do multiple things at once, okay? So my first step is to say, hey, I need to do the vertical stretch by 1, and I need to do vertical reflection. Combined, it means my y coordinates are multiplied by -1. Okay. So starting off with the vertical asymptote. Vertical asymptote doesn't change. 0, 0. What is 0 times -1? 0. So that doesn't change. So after the transformation, my next step is to do wink. Now it's going to look like this. I already did my vertical stretch by 1, and I did my vertical reflection, yes. So cross it off. My first two homework already complete. Next step, horizontal stretch by 4 and no horizontal reflection. So obviously that's already done. Horizontal stretch by 4, what does that mean? It means your x coordinates are multiplied by 4. X coordinate multiplied by 4. So what happens to my vertical asymptote at negative pi over 2? Negative 2 pi. Negative pi over 2 times 4 is negative 2 pi. So here's a little trick that you can use. Just cross off and say negative 2 pi. Same thing here. Say 2 pi. Hey, what about the 0, 0? What is 0 times 4? 0. So at this point, I already did horizontal stretch by 4. Let's cross off the vertical translation by 0 already. My final step is to do horizontal horizontal translation by pi over 2. I want to move everything by pi over 2 to the right. It means all my x coordinates are added by pi over 2. Starting off with the vertical asymptotes. X equals negative 2 pi. What is negative 2 pi plus pi over 2? Negative 3 pi over 2. So I think at this point, let's draw a new one. Perhaps below. So just a bit to the right. X equals negative 3 pi over 2. What about x equals 2 pi? What is 2 pi plus pi over 2? 2 plus 1 over 2 is 5 over 2. So I think it'll be a bit more to the right. Not that it's so important. So if my second vertical asymptote x equals pi over 2, 5 pi over 2. Finally, where is my x-intercept? It used to be 0, 0. What is 0 plus pi over 2? Pi over 2. So that's my x-intercept. And then all the graph just moves along with that. So, yay me. And if you want, you can just repeat this. Like that. Should I dance in happiness? Am I happy?
Yes.
Am I happy?
Yes.
Should I move on to the next question at this point? I shouldn't. I have yet to find one time. My grammar is really bad with the word yet. I have yet to find one more thing. Is that the right thing? I am yet to find one more thing. I need to find the y-intercepts. It used to be just 0, 0, so I didn't have to bother at all. But now I need to find the y-intercept. Well, good news is that y-intercept is always the easier one to find, isn't it? So let's find the y-intercept by just plugging in x equals 0. So that's negative tan of 0.25 times 0 minus pi over 2. Close, close. What is that equal to? Time to use the calculator. Negative tan, 0.25, 0 minus pi over 2. Close, close. We got 0.414. So that's going to be 0, 0.414. Now I'm happy. If you want to label more x-intercepts, you would like to. My period used to be pi, but now it's 4 pi. So pi over 2 plus 4 pi is 9 pi over 2. Minus 4 pi, negative 7 pi over 2. If you wish to find more x-intercepts, negative 3 pi minus 4 pi, negative 11 pi over 2. And then 5 pi over 2 plus 4 pi, 13 pi over 2. If you want to find it. Yep.
So for the tangent, if you just find the y-intercept, we don't have to find extra x-intercept.
Well, in this case, we were lucky that we didn't have to. Partially because d equals 0. If my d was non-zero, if I had to move up by 1 or down by 1 or whatever other number, then we would have known the midpoints, but we wouldn't know the x-intercepts. So then we would have to calculate your x-intercepts. In the language of our test, I would call this intermediate level question, because you don't have to calculate your x-intercepts. I think the next one, the question 6, you'll have to manually calculate your x-intercept. So, have fun with that. Once again, same thing for this one. Do you need to use transformation? Not at all. Do I suggest that you use transformation? Personal suggestion? Yes. Personal opinion, I think transformation will be easier for this text, for this question. Not a mathematical fact. Just personal opinion. All right. Any more questions about this problem? Move on to the next. Final page, question 7. Sorry for the print, this one. I forgot to put the vertical asymptotes. The actual graph is kind of like this. X equals negative pi. X equals positive pi. And the graph goes like that. So I want to find the equation of this graph. Well, always, the first question is, what is the core of this function? Can you tell? What does this graph look like? Tangent function. So the core is tangent. Now I know my core. I suggest that you draw the core function on top of the given graph. So if I do that using the black color, I think the graph will go like that, with the first vertical asymptote being at x equals negative pi over 2, and the second one being at x equals pi over 2. We share the x and y intercepts here. So once again, the question is the same. How does black graph, my core function, how did it become the red one? It's like, when your partner asks you, hey, did anything change? And then you have to guess, is it a hairstyle, is it a makeup, is it an outfit? What changed? Well, the good news is that we only have few things that could have changed. We only have 6 of them. So we go through the list and say, oh, this has changed, or nothing has changed. Starting off with the vertical stretch. Is there a vertical stretch for this question? The answer is we don't know. We don't know whether if there is a vertical stretch or not. I'll calculate that later. For the tangent function, we don't know the vertical stretch right away because we don't know the amplitude. There's no amplitude of the tangent function. For the sine and cosine graph, there was an amplitude, so it's quite easy for us to measure what the vertical stretch is. For this one, we won't know the vertical stretch. What about the vertical reflection? Is there a vertical reflection? Sure. Yes. Sure. I say sure because if you say no, that's okay. You can just say there's a horizontal reflection instead. For that purpose, I'm just going to say no just for fun. Whatever you want. Next, horizontal stretch. So I'm just going to say yes for horizontal reflection here instead. Is there a horizontal stretch? Yes. By how much? My period of the original core tangent function used to be pi. But what is the resulting function's period? 2 pi. So what does that mean? Pi to 2 pi by 2. Horizontal stretch by 2. And multiply it by 2. Yep.
Why yes to the horizontal reflection?
Because for the tangent function, it doesn't matter whether I flip it upside down or left and right. And just for fun, I put yes for horizontal reflection.
So it doesn't matter.
It doesn't matter. If you want to say yes here and no here, that's also okay. It just can't be both yes or both no. What about my horizontal translation? Did my graph move left and right? The answer is no. So by 0. My last one is the vertical translation. Did my graph go up and down? And by how much? Well, unlike the vertical stretch, we can actually know how much the vertical translation is. Sometimes you can find it directly by looking at the graph, or sometimes you know there is one, but you have to calculate it. It's by looking at the midpoint. My original black graph has a midpoint at 0, 0. It's in the middle of the 2 vertical asymptotes. So we're in the standard position. What about my red one, my resultant one? Well, the midpoint, which is in the middle of negative pi and pi, it's 0, and it's also in 0, 0. So I think we can easily deduce that there is no vertical translation. This is not always the case. If your x-intercept, for example, is not the midpoint, then you should assume that there is a vertical translation that you have to calculate. If that's the case, then we'll have to solve the systems of equations to find the A and B value. Anyways, I have everything except A. Right? I have my B value, horizontal stretch by 2, and yes reflection, so B is equal to -1/2. C equals 0, D equals 0. A is just unknown. So it means my equation must be y equals A tangent of -1/2 x. What is my A value now? How should I calculate it? Using the point. So I think we can use this point here and say -1 is equal to A tangent of -1/2 times pi/2. And let's use the calculator to compute that. tangent of -1/2 times pi/2 is -1. So what is A here? So A is 1. So my answer for vertical stretch was there was a stretch by 1. So my final equation is just y equals tangent of -1/2. Any questions about this process here? Now, here's my honest opinion. I truly believe that transformation method is easier if you want to go equation to graph. I think transformation is slightly easier for graph to equation. That's my opinion. And your opinion may be different. So if you think that you have a better method that works for you, then go with that. The end result should be the same though. If you have a graph, it should include all the max and mins and the intercepts. If you're finding the equation, it should be a correct one. Well, it may be different styles. For example, it could be -tan of +1/2x. That's okay as well. I'll accept those answers. As long as you show the steps and it is the right answer, I'm happy. If you show the correct steps and got the incorrect answer, well, so a mistake. If you didn't show your steps and got the incorrect, well, that's incorrect. If you didn't show steps and got it correct, that's also incorrect. They should show your steps. Once again, what I did was just top 4 questions. So that means that you have the bottom 4 questions for you to practice. You also have the checkpoints from a while ago, and you have your quizzes that you have taken a while ago. I've given them back to you, right? So I suggest that, especially the questions that you got it incorrectly or made a silly mistake, make sure you fix those and say, why did I got it incorrect last time? So you do that question and you notice, oh, this is where I made a mistake, and you try to fix it. Or if you made a silly mistake, same thing. Oh, this is where I made a silly mistake, and you fix that. Oh, I didn't label the y-intercepts here. Well, don't skip the y-intercepts next time for the same reason. You don't want to get the silly mistake for the same reason back to back, right? That's why I give the quizzes back to you, right? So you can reflect on it and do better on the test. Also, if you want to practice your trig equation skills, that's back in Unit 1. So it's been a while, so dig it and find some checkpoints. They're all visible on Google Classroom as well.
But we don't need to know about this, do we?
Well, I think
We're
for
not getting tested on trig equations, just graph it.
you had to use a trig
Yeah.
equation here.
But
There was no other
it's
choice.
It's all graphic questions, right?
It's all graphic questions, but
If you want to practice.
no. Because some questions will be inevitable that you calculate your x and s. I'll design the question so you have to use trig equations.
Okay.
Not for like beginner level questions. Okay. All right. I didn't include the modeling part, so make sure you review those as well. The word problems. Word problems are basically just like graph to equations, so I think it's the same thing. All right. I think that's it.